Okay guys, is my screen visible? Are we good to start? Okay. Okay Chaitanya. Okay. So today I hope the concepts were very much clear about the yesterday's topic. Yesterday it was a very simple topic. Okay, super keyword in Java, right? And so there are three places where you can use this super keyword. One is to refer the immediate parent class instance variables, immediate parent class instance methods, and what you can also use this super class super constructor call to refer to immediate parent class constructors. We have seen some problems on top of this topic, right? I don't think much explanation is required. Okay. So the concept of super keyword is successfully completed. Today the topic is the typecasting. So when I say typecasting, it is the class level typecasting. So please please do some focus here. Class level typecasting. So this is our topic of discussion for the day, for today. Okay, so we know what is a typecasting. The moment I say typecasting, it is nothing but it is talking about the conversion. Please remember, the moment I say typecasting, it means converting from one form to another form. Okay, simply I can define it like the process of converting data. The process of converting what? The process of converting data from one type to another type is called as what? Is called as what is it? Okay, is called as typecasting. Okay, it is called as typecasting, but what is class level typecasting? That is our discussion today. Okay, so usually we have already discussed something about this typecasting in the concept of primitive data types. If you don't remember that, please repeat my video. Right, I have already discussed about the typecasting. So how to convert from integer to float, right? How to do the conversion from float to integer. We have seen these things practically. A lot of explanations were given on top of it, right? So we are not going to discuss much about that. Okay, there are actually there are two types of typecasting in Java. Okay, the first type is primitive data types typecasting. Primitive data types typecasting. Okay, we do not have to discuss about this topic has been discussed already. Do you remember guys, I was giving you to do the conversion from one data type to another data type. Do you remember this concept byte, how to convert from byte to short, from short to integer, from integer to float, right? From float to integer to long, we have from long to float, right? From float to double, right? We have discussed how to do the conversion from lower data type to higher data type, from higher data type to lower data type. When you do the conversion from left to right, it is explicit typecasting. When you it is implicit typecasting, right? Lower to higher is called as what? The implicit typecasting. From higher to lower, explicit typecasting. We have discussed this topic already. There is nothing to be discussed once again. I just want to give an introduction. That's why. Okay. The other typecasting is user-defined typecasting. User-defined data types typecasting. Right. So is there anyone who is getting the cue? Okay. Right, these are the two prominent typecasting. These are the only typecasting that we have in Java: primitive data type typecasting and the user-defined data type typecasting. So what is primitive data type typecasting? What is primitive data types typecasting? Okay, very simple. The process of converting data from one primitive type, from one primitive data type to another primitive data type is called as primitive data types typecasting. So we have discussed these things already. Okay, I am just giving an introduction, that's it. Okay, and again these primitive data types are categorized into two types. Okay, they are categorized into how many types? Into two types, right? One is implicit typecasting. Okay, second one is explicit typecasting. Okay, and again under implicit typecasting we have what? So the definition is very simple. Again, the process of converting data from lower primitive data type to higher primitive data type is called as implicit typecasting. Okay, what is explicit typecasting? Same thing, and it could be written in vice versa. The process of converting data from higher primitive data type to lower primitive data type. Okay, the reason why I am giving this much explanation is we have to discuss about this user defined data types. Before even discussing about this user defined data types, I am just giving you a foundation level introduction of primitive data types, which has been discussed already. Do you remember this topic, yes or no? Typecasting. Anyone? Do you remember? Have you forgotten this topic? At least you remember that I have taken this topic in the previous session. Darshini, you remember? Okay, if you don't remember, you can repeat that video once again. Okay, so we have already discussed this. I am just giving an introduction, a brief, just a small briefing I am giving. Okay, so now we have to discuss about what? User defined data types typecasting. This is our actual topic of discussion. Okay, very simple, definition wise it is very simple, but concept wise there will be little confusion. Don't worry, I am going to clear our confusion. Okay, so the process of converting from one user defined data type, one user defined data type to another user defined data type, is called as primitive data types typecasting. Again they are categorized into two types. Just copying and pasting, but I am doing a little modification. You need to observe them. They are categorized into two types. One is upcasting. Okay, so you need to get acquainted with this terminologies. One is what? Upcasting. Second one is what? Downcasting. So what is this you are saying? You are giving a lot of theory. Why you are giving a lot of theory before even getting into the program? We need a practical explanation. That could be your question. Trust me, we are going to see these things practically, but let me complete the theory first. Right? So upcasting and downcasting. Okay, let us start discussing about this upcasting. Let us start discussing about what? Let's start discussing about this upcasting. So upcasting, definitely you can define it like, okay, there is no universal accepted definition. I can define it like, if you want to perform upcasting, or else simply, you know, instead of doing all these things, I can also say it like, it is a process or it is a mechanism. It is a mechanism to convert subclass type to the superclass type. What does it really mean? Upcasting, I am saying it is upcasting. I am just saying upcasting is a type of, I know it is a mechanism, or I can say that it is a type of typecasting. Okay, let me say it like this. It is a type of typecasting in which a child object is typecasted. Typecasted means converted. Typecasted to the parent object, or else I can say that parent class object. right? Parent class object. Now it is making more sense. It is a type of typecasting in which a child object is converted to the parent class. Okay. Definition wise, something is written, so we are not able to understand what is this thing, what is this conversion. Okay, let us look at this, look at these things in the diagrammatical representation, so that you people will get much idea, right? Shall we proceed now? See, every time when you are talking about is a relationship, when you are talking about this typecasting concept is always can be, is always or can be always achieved in is a relationship. What do I mean? Is a relationship, or I can say that in the inheritance relationship. Okay, every time when I talk about inheritance relationship, there will always be a parent class, yes or no? There will be two classes. Okay, so if you have two independent classes, it is not talking about is a relationship, right? When you want to represent a is a relationship, there should be a relationship between two classes, right? So there can be a parent class. Okay, there can also be a child class. Okay, since this is a parent class, and this is parent class, and we have what? We have another class called as what? Child class. We have parent class and we have a child class. Okay, the upcasting, I'm talking about what? Upcasting. So this concept is called as what? Upcasting. Okay, diagrammatically, what did I just do? Okay, I have just specifying an arrow mark. Okay, it is not a meaningful thing. Let me introduce it to you. So this part is called as upcasting. Okay, now you see upcasting. Okay, this part is called as downcasting and upcasting. Diagrammatically, it is good. Go back to the theory. What my theory says, it is a type of casting. It is a type of typecasting in which child object is typecasted to parent class object. Right? This child object is typecasted to the parent class object, or else you can also say it like when you it is a process of converting subclass type to the superclass type. It is a process of converting what? Subclass type to the superclass type. Okay, so usually what is an inheritance, guys? So this is the inheritance. Okay, so this is what the extends keyword is talking about. Okay, when you use extends keyword, it means you are defining a relationship. So there is a parent class and there is a child class. Because of this extends keyword, we can differentiate which one is parent class and which one is a child class. Yes or no? But typecasting is a different concept, guys. Typecasting is different concept. It is a process of converting. It is a mechanism. It is a process of converting subclass type to superclass type. Okay, how this can be imagined programmatically? Let us understand that. Okay, so this is the theory. For now, just try to stick to this theory. Just try to do what? Just try to stick to this theory. Okay, I will clear your confusion. This is the theory. Just try to stick to this theory. To understand this practically, I want to introduce two classes. Okay. I want to introduce what? I want to introduce how many classes? I want to introduce two classes. Okay, I have a class mobile. Okay, in the mobile class, I want to take a method void. Okay, the name of the method is calling method. Focus here, guys. Focus here. The name of the method is what? Calling method. Okay, so we have a calling method. Inside this calling method, I just want to print something in the console to check whether this method is able to be this method is actually got invoked or not, or accessed or not. Someone has just joined in. Let me quickly get that person in. Okay. Okay, system.out. What is it? I'm sorry, print eln, right? So when this method is called, okay, I want to display something in the console like calling, right? Mobile class is there. Inside the mobile class, I have taken one method. right? And so this is going to do what? If you invoke this method, it is going to call a simple call, right? I'm taking another class now. Now focus here. So the name of this class is iPhone. iPhone, very what do we call it as iPhone? Very famous phone. Everyone likes an iPhone nowadays. iPhone. So inside this iPhone, I am doing what? I am taking another method. The method name is same. If you observe one thing, I have two classes. In the two classes, the name of the method is same. Okay, inside this, I want to display something in the console, calling from iPhone. Calling from what? iPhone. Okay. And I am also taking a main method, public static void main. Okay, string array aux. Okay, so this is the main method. Okay, now I want to make a relationship. Now so far I have a mobile class. Inside the mobile class I have a calling method, and I have an iPhone class. When I say iPhone class, the name of the class is iPhone. That's why I'm saying it is iPhone class. Inside the iPhone class I have an method, and the method is what? Name of the method is calling. Okay, and also I have placed the main method. Okay, so far so good. I want to create a relationship. Okay, so I'm using what? Extends mobile. I can also say that iPhone is a mobile. Can I say iPhone is a mobile? Why the is a relationship as came? iPhone is related to a mobile. iPhone is also a mobile. iPhone is a mobile. Is a relation. Okay, so Java will not accept is a. iPhone is a mobile is a language that can be accepted by you and me. Everyone, we understand English. But Java, in order to make it understand that these two classes are in a relationship, okay, remove this is a and use extends keyword. Now it's perfect. Okay, there are two classes, and we have what? I know we have some methods inside, and we have also a main method. Okay, this is how it is. Okay, now you see, my intention is I can create object in how many ways? I can create object in two ways. Okay, what is the first way? I can create object mobile m equal to new mobile. This is one way. Okay, so parent class, parent object. Secondly, I can also create object Samsung s equal to, I'm sorry, my phone is Samsung, that's why I'm typing it as Samsung. So iPhone I equal to new iPhone. Okay, object is created for what? When I ask you, okay, this is one object creation and this is another object creation. Okay, this object creation is like parent to parent, right? So parent reference and parent object. Okay, and these object, the second object is like child to child. Right? Child, child reference, but child object. Okay, there are other ways to create object. What is the other way, guys? Okay, so this is the ordinary way. Okay, see, let me keep it separate. These are the actual ways. When I create object for the mobile class, I can access this calling method by using this reference m dot calling. If I do m dot calling, okay, calling will be displayed in the console, right? But when I use this reference, I is of what type? iPhone type. When I do I dot calling, this will be displayed in the console. Yes or no? It is very specific. We are being very specific, right? See, I can do like this for you. M dot calling. Okay, which calling method will be displayed? Executed. This calling method will be executed, right? And I dot calling. Okay. Which calling method will be executed? This calling method will be executed. This calling method will be executed. Yes or no? You agree? Now we know this there is some plot here. Now what I want to do, I want to do the typecasting. I want to introduce the typecasting concept now. Okay. What I want to do here, I want to create an object for the, let us create the object for is iPhone I equal to new iPhone. I want to do the typecasting. I want to do the upcasting. What is the theory says? This is a type of typecasting in which child object is typecasted to the parent class object. Please remember this. Child object is typecasted to what object? The parent class object. Right? So this is the child object reference. This is child object reference. Okay, I want to use that reference to convert it to parent class. Child object. This is a child object reference. This is child object reference is typecasted to. So I need to use a typecast operator. So this is a typecast operator. This is what? This is the typecast operator. Is typecasted to, right? This typecasted to parent class object, right? Yeah. Any confusion? Yes, sir. There is a big confusion here. Of course, there is a very big confusion here. I'm sorry. I'll say this one is mobile. I'm sorry. Parent class object. PAL. Right? Okay, look at these two lines. Okay, look at these two lines. Okay, so this part is talking about the object creation by using the child reference and the child object. Okay, but this line is talking about something. It is talking about something. It is giving us some meaning. For now, it is what it is giving us some meaning. It is somewhat meaningful. How it is somewhat meaningful? We are using this reference variable I. Okay, and we are typecasting this reference to which class type? Parent class type. Right? Let us keep it as M itself to avoid confusion. Parent class type, and we are using the parent class reference variable. Okay, go back to the theory now. It is a type of typecasting in which a child object is typecasted to the parent class object. Okay, let me draw a quick diagram. Okay, we have a child now. For now, we have a child. Okay, we also have a parent. Right, and there is a relationship between these two. Yes or no? There is a relationship between the child and the parent. Right, and so this is what? This is mobile. Mobile is a parent. Okay, right, and this is iPhone. iPhone is the child. Right, inside the iPhone class, how many methods are there? There are two methods. One is forget about the main method. Apart from main method, there is a method called calling method. Inside the parent class, there is a method called calling method. Each and every class has its own method. Okay, this is the extends keyword relationship. This is extends keyword relationship. Now what I am doing it here, look at these two lines. Okay, this first line is talking about the object creation of the child class. Okay, I am using what? Child equal to child. Child class reference to the child class object. Right, so because of this, it is just like, okay, this object, iPhone object, has got a what? Has got the reference I. First line is very clear. This iPhone object has got the reference. Right, now look at the second line. This is the confusing part. This is the confusing part, which is called as the typecasting part. Okay, what we are trying to do here, what we are trying to achieve here, we are saying that this reference, this is the iPhone reference. Typecast this iPhone reference to the parent class reference. What does it mean? Typecast the iPhone reference to what? To the parent class reference. So this is how it looks like. Internally, okay, this conversion is happening. Okay, you are saying this I variable is representing what? This I variable is representing of what type? iPhone type. This I variable is representing iPhone type. But after the typecasting, after this particular line, after the typecasting, okay, this I variable is typecasted to what? The mobile type. Typecasted to what? Mobile type. This process is called as what? Upcasting. First, try to understand the process. The process we are talking about. Okay, we are not talking about the benefits and advantages. We are talking about what? The process. So first, stick to the process. This process is, we have achieved something, they're trying to do something, that something is a process, that process is called as typecasting. Then what are the advantages of doing this, that we will understand later. This process is called typecasting. What kind of typecasting is this? This is called as what? Upcasting. Okay, I'm just giving the real meaning to the definition, that's it for now. It's a type of typecasting in which the child object is typecasted to the parent class object. We done the same thing. This is how it can be imagined from the diagrammatical representation. It's a process of typecasting for the child object is converted to the parent class object by using what? By using the typecast operator. I can add this also, right? Using the typecast operator. Okay, this is the typecast operator. Okay, just say something in the chat box. Have you understood the theory and the practical diagrammatical conversion? Just give answer to that. What are the advantages? Why we are going to do that? That we will understand later. Are we clear with this theory? Okay, I just want to explain you this theory. I want to convert this theory diagrammatically, so I did the conversion. That's it. Apart from that, I did not do anything. This is the internal conversion. We are talking about the conversion. What are the advantages that we are going to see now? What are the advantages that we are going to see the advantages now? Right? Now let us focus on these two lines. Let's focus on these two lines. Okay, we have achieved something with these two lines. Okay, we have achieved something with these two lines. So, line number 1 and line number 2. Okay, instead of doing like this, I can also do what? I can directly do mobile m equal to new. Okay, it is like no. The second line says mobile m equal to mobile I. Okay, I can also convert this like mobile m equal to mobile. This I can be replaced. I is pointing to which value? This I. Look at this I. I is pointing to which value? New iPhone value. Some value is there, right? New iPhone. Okay. Instead of doing these two things, okay, I can do what? I can directly do this. Okay, these two things are equivalent to this one line. Both are same. You can do this way or you can do this way. This you need two lines of code. Okay, the same two lines can be achieved by using one line. Okay, this part is called as what? What is this part? What does it says? What does this topic is all about? Upcasting, right? All about upcasting. Okay, and again this one line is so powerful enough to be called as what? Upcasting. Both are same. Okay, so when you talk about upcasting, you're talking about the conversion from the subclass type to the superclass type. This is optional. This part is also optional. Means this can also be modified like what? Mobile m equal to new iPhone. All these three lines are giving the same meaning. All these three lines are talking about all the three steps are talking about what? The upcasting. All the three lines are same. All these three conversions are same. Okay, this is also, these two lines of code is also giving the, you can understand the topic of upcasting, and this one line is also representing upcasting, and this line you can eliminate mobile. It is not necessary that you need to keep, because if you remove also no problem, internally it is upcasted to mobile only. So this part is also talking about what? Upcasting. Okay, all the three differences what I am talking about, all these three separators are talking about what? Upcasting. You can define this like way. You can also define this like way. You can eliminate this mobile. You can remove this cast operator. You can remove this. You can remove this cast operator. Simply you can do this. Mobile m equal to new mobile. Okay. Internally this this part. Okay. Internally this part is going to have this cast operator mobile. Okay. Internally this part is going to have what? The cast operator. Right, internally is going to have let me write it for you, let me write it down for you. So this part is going to have something like mobile. My pen is not working. Try to imagine. Okay, all these three are giving the same meaning. Okay, so upcasting definition wise it is okay, and diagrammatic wise it is okay, and our understanding is okay with the theory. Our understanding is completely okay with the theory, right? So what are the advantages of upcasting? What are the actual advantages of upcasting that we are going to discuss now? For that, let me write the same program. Let me remove all this. Okay, so we have a class. The class name of the class is mobile class. Okay, we have another class, iPhone class. Okay, this mobile and iPhone class is having a relationship, extends mobile. So far good. So far good. Right, now I want to add a method, void calling method, so I am going to take a statement, system dot out dot println. Okay, simply I want to display something like calling. Let me copy the same method and paste it here. This time calling from iPhone. Right, and let me take the main method, public static void main string array args. Right, perfect. Our program is perfect. Now you see, guys, so I have I can create objects in two ways. One is, okay, since I am using extends keyword, I can create object for child iPhone obj equal to new iPhone. This is possible, right? I can create object for parent, right? Mobile obj1 equal to new mobile. Okay, now you see the difference. So with the iPhone object reference variable, I can do what? I can call obj dot calling. Okay, when I call obj dot calling, definitely obj is of iPhone type. Okay, and it will try to identify for the calling method. It will try to identify for the calling method inside the iPhone class. It will check, is there any method by the name of calling? Yes, there is a method by the name of calling. So this will be displayed in the console. No, good, very good. Now, with the help of mobile reference, obj1 I am saying dot calling. Very specific. obj1 is of what type? Mobile type, right? So we are calling obj1 dot. We are calling a calling method of mobile type. Okay. Now the control will be transferred to the mobile class, and it will check, is there any method by the name of calling? Of course, there is a method. So this will be printed in the console. So far good. So this part is P to P, parent, I mean C to C, child to child reference, child object. Okay, and this part is parent to parent. No issues. Right? Let us run this code first. File, save as. Okay, the name should be iPhone.java. iPhone.java. Right? Saved. Let me open the command prompt. Okay, command prompt is open. Let me change the directory quickly. cd space java 3 we have, right? And java c space iphone dot java. Okay, compilation is successful, java space iphone, right? Calling from iphone and we are calling. Okay, respective methods are getting executed. There is no rocket science here. Obj dot calling, the respective method of obj, obj is of iphone type. So this calling method is executed. That's why the first thing, the calling from iphone. Second is calling. Why calling? obj1 of calling. obj1 is of what type? Mobile type. What is the method inside the mobile? What is the logic inside the mobile type calling? Only calling. So for code. But let typecasting. Now we understand about upcasting. What is the upcasting? What is upcasting? Placing the child class. I mean converting the child class object type to the subclass object type to the parent class object type. Right? So I can do what? Okay. So this is obj1, right? This is the subclass. I mean this is the child class, child. Okay. Obj is converted to parent. Parent is what? Mobile. Okay, by using the typecast operator. Okay. Child class reference is converted to parent class type by using typecast operator and assign it to the parent class type. Mobile obj, right? Upcasting, this concept is called as what? Upcasting, right? To understand this, okay, I want to print all the reference variables, system.out.println, right? System.out.println, right? And again let me also print system.out.println. I want to print the reference values obj. This is ordinary. First two things are very common, very ordinary. This is somewhat, I know this is going to be confusing. I will clear your confusion. Upcasting, this concept is called upcasting. Theoretical upcasting is what? Converting the subclass type to the superclass type by using the typecast operator. This is a subclass reference type, right? Obj is a subclass type or the child class, I can say. The superclass, parent class, and assign it to the parent class reference, right? So already obj1 is there here. Okay, let me take it as obj2. obj2. Okay, let us execute this. Java c space iphone.java, java space iphone. Okay, see now by this we are going to learn a lot. We got some output, right? Okay, got some output. Let me paste this output here. Okay, let us open the paint screen. Focus here, guys. Very important. Focus here. This is theory. I don't think this part is required for you. Okay, now let me so this part is output, right? Let us do some. Okay. Let's remove this. What I can do, I can copy this part. Okay, this is mobile class, right? And let me paste it here. Okay, let me remove this. This is the output. Perfect. Okay, now see what is happening. Now you see, so because of this extends keyword, okay, what is internally happening? Okay, and don't you think that there is a relationship, right? So we are going to have one object, or this is the subclass type, and this is the parent class type. Okay, because of this extends keyword, okay, there is a relation, right? And this is talking about what? Extends, right? Extends, right? And this is iphone, subclass is iphone, parent class is mobile. subclass is iPhone and parent class is mobile. Now you see guys, okay, let us start. Okay, and again this has one calling method. Okay, this also has one calling method. They have individual calling methods. Both the method names are same, but the logic is different. Try to observe that logic is different, right? Now you see the execution always starts from main method. The execution is always going to get started from main method. Yes or no? Okay, first we are creating an object for the iPhone. Okay, there is a reference variable created obj. There is a reference variable created obj. Let us assume that this is a reference variable obj, and the second call is we are calling obj.calling. Okay, this obj is going to call this calling method, right? Obj is going to this calling. Output is going to be what? This calling method will be executed. So ideally, so this is going to be another console. Good, so far good. Okay, and again now the object is created for parent. Okay, what is the reference variable for this parent? obj1 or no, right? This is what obj1. Okay, let us take it as obj1, right? And the next line is you are calling obj1 dot you're doing what? obj1 dot calling. So this calling method will get executed. Of course the respective functionality or the respective logic will be displayed in the console. Okay, now this part is, this concentration is required, upcasting concentration. Okay, now we are doing what? We are doing we are doing a typecasting. Okay, so there is an object, okay, this obj, this obj, we intentionally converting it to what? We intentionally converted into what? We are doing the upcasting. So a typecast operator is used, right? A typecast operator is used. You are saying, of course this is the reference variable of the child object, but convert this reference variable to the typecast this reference variable to the parent class object. For that you need to use the typecast operator, which is mobile. Mobile is a parent class. So this is the conversion. So this has been converted, right? And now you see, next thing is what we are trying to do it here. We are printing obj. Okay, obj means this the toString method will be called, this address will be printed. This address will be printed, and we are calling what? We are printing obj1. This address will be printed. Okay, we are calling obj2. Which address will be printed? We are calling what? obj2. Which address will be printed? Okay, for the obj2 also this address will be printed. Why obj address will be printed? Because we have typecasted obj to obj2. We are assigning obj to obj2, right? So there is a variable called obj2. There is a variable called obj2 which is pointing to the same reference, right? That's why in the console we got the output like, okay, first this value and the last value is same. Even though you do the typecasting, okay, the parent class reference variable is pointing to the child class object reference. Okay, that's why the values are same here. The values are same, right? So what we have achieved? What is this all illogical thing? So what we are going to with this concept? We are so happy with this child to child, parent to parent. Why I have to introduce something like parent to child? Why I need to do this typecasting, parent to child? What is the benefit? Okay, this typecasting concept is a topic in polymorphism, in the future topic polymorphism. Now try to understand the benefits. Okay, see, I am going to remove these two. Okay, let me add one more method, void. This time I want to add a method like void calling void camera method. In the iPhone there is a new feature, additional feature is there, void camera feature is there. Okay, I am taking pictures from iPhone. Okay, so in the parent class, in the mobile class there is only one method, but in the child class, okay, in the iPhone class there are calling method, there is a camera method, of course there is a main method. Okay, now you see guys, if I create an object, let me remove this, remove all this, let me remove this also. Okay, now object has been created for iPhone, obj equal to new iPhone. Good, right? And you are able to call obj.calling. Also you can call obj.camera. Don't you think so? Let me remove all this for the now. Let me remove all this. Okay, now you see the advantage, each and every advantage with the child class, with the child class reference variables. Just try to understand, child equal to child. A child class reference and the child class object. iPhone equal to new iPhone, iPhone obj equal to new iPhone, child. With the child class, with the help of child class reference, I can call calling method. Okay, when I call calling method, this calling method will be executed. When I call camera method, this camera method will be executed. Right? I can print, I can execute all the methods with the child reference. Right? Now you see the output. Calling from iPhone, I am taking pictures from my iPhone. Okay. Now with the parent class reference, with the parent class reference mobile obj equal to new mobile, right? obj1. With the parent class reference, I can call only the method, specific methods that are in the parent class. What is the specific method? I can only call calling method because child class properties and behaviors are not available to the parent class. Inheritance concept, but parent class reference variables are available to the child class, but child class variables as well as the behaviors are not available to parent class. So only one method, only specific methods inside the parent class can be called. Very simple. With this, okay, with this I can call both child as well as parent class methods. Okay, yes or no? Okay, but with this I can call only parent class methods. Okay, let me run this. Okay, calling from iPhone. I am taking pictures from iPhone. Calling. Okay, instead of just printing it as a calling, okay, let me do it till calling from mobile. Okay, now you see. Okay, calling from iPhone. I am taking pictures from my phone. Calling from mobile. Now you see. Now the upcasting concept. What is upcasting? So this is parent to parent. Parent to parent. Now upcasting concept. Upcasting. What does upcasting says? Use the child class reference, subclass reference. Okay, mobile. I mean this subclass object. Choose the subclass object iPhone. Okay, convert the subclass object, or you can say that convert the subclass object type to the parent class object type. So new iPhone equal to, in the left hand side I am pasting mobile m1 equal to new iPhone. Okay, this is making sense. iPhone obj equal to new iPhone, making more sense. Mobile obj1 equal to new mobile, maybe making more sense because in the left hand side and the right hand side both are the same type. But here left hand side is the parent type, right hand side is the child type. Do you agree? Parent to child. Typecasting. Internally, compiler is going to do what? Internally, okay, this operator will be added by the compiler. Both are same. You can also do like this, converting the child class type to the parent class type and assigning it to the parent class variable, or else you can remove this, no issues. The question here is, my question is, by using this m1 reference, which method we can call? By using this m1 reference, we know by using this reference variable we are able to call two methods. By using this obj1 we are able to call one method because only one method in the mobile class, right? Now by using something, this is something different. Okay, parent child class object is assigned to the parent class reference variable. Which method can I call? Can I call camera? Can I do that? If I do this, okay, let me see. If I do this, we will get error. Cannot find symbol. Okay, cannot find symbol. Okay, it is very specific. Okay, if you are just look at this left hand side part, by using this mobile reference, you cannot call any specific method from the child. I mean, this camera method belongs to child class. Yes or no? Camera method is part of the child class iPhone. You can call only the parent methods, parent class method. Okay, in the parent class method, calling method is there. Okay, let me call that. If I call this, I would be expecting an output like calling from mobile. I would be expecting an output like calling from mobile. Why I would be expecting this output? Because M1 is of mobile type. Mobile, inside the mobile, I have a method calling method which is going to display calling from mobile in the console. I am expecting this, but let us see what is actually happening behind the scenes. See, calling from iPhone is getting printed. I am calling something, I am expecting something. Okay, this M1 is of mobile type. Of course, the controller has to go to the mobile class. Okay, there is a method called calling. I am expecting this to be printed in the console, but instead of this, this is getting printed. Why this is happening? Because of typecasting, this is happening. Now I will explain. Now you will get much clarity. Okay, let me take this to the paint screen. Okay, now, okay, let me remove this. Save as. Okay, upcasting. Okay, file, new. Yeah. Now see what is happening. What is the beauty of this typecasting? Now you see. Let me separate this two. Okay, I think it is visible now. Okay, so we have a mobile class and we have what? We have iPhone class and we have a main method. Okay, now let us start the tracing part from the main method. First is an object is getting created for iPhone because of this new keyword. This part, understand this part. Understand this part. Okay, iPhone obj equal to new iPhone. Okay, object is created because of the new keyword, and this is going to be what referred as, what is it, obj. It is going to allocate what, how many methods are there in iPhone class. We have calling method apart from main method. Forget about main method. We have a calling method and we have camera method, right? So there is a calling method. Okay, there is a camera method. Okay, good. This part is completed. Right now, what is the first call after this? Okay, what is the call? First call obj dot calling. Of course, when I do obj, by using this obj, I am calling the calling method. Okay, this method will be executed. Of course, this method belongs to which type? iPhone type. iPhone type. So what needs to be displayed in the console? Let us imagine this is a console. This is iPhone type. iPhone calling method of iPhone will be displayed, right? So what is the calling method inside the iPhone? Calling from iPhone will be displayed. Calling from iPhone. Right? What is the second call? obj.camera. 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 Calling, I mean, camera method inside the iPhone. Camera method inside iPhone will be executed. Right? What is the camera method says when you execute it? I am taking pictures from the iPhone. I am taking pictures from what? iPhone. Good. Next line. Next thing. Okay, this part is done. Okay, and we are creating objects for mobile. Ideally, for the mobile also, an object will be created, right? And it is going to get a reference. What is that reference? This one. Sorry. obj1, obj1. Okay, it is going to what? So in the mobile class we have only one calling method, right? So the control will jump to the next line. Okay, obj1 dot calling. Okay, this is obj1, guys. I did a mistake. This is obj1. obj1. Okay, this obj1, by using this obj1 we are calling which method? We are calling the calling method of which class? Of the mobile class. Of the mobile class, right? So the output is going to be this part will be executed. So calling from mobile will be displayed in the console. Calling from mobile will be displayed in the console. Okay, now these three things are so clear for us, but the problem is with the upcasting. Okay, the problem is with this. We have a problem with this one. Mobile M1 equal to new iPhone. Mobile M1 equal to what? New iPhone. Okay, so let us create an object for because of this new keyword, an object has to get created, right? And this is going to get a reference variable. Okay, this part is iPhone part, object is for iPhone, but reference variable is talking about M1. Your reference variable is what? Of mobile type, M1 type. M1 is what? Of what type? Mobile type. Typecasting has happened. M1 type is mobile type, but object has been created for what? It has been created for iPhone, right? Now see, this iPhone is going to hold how many methods? Calling method, right? And camera method, right? Now what we are trying to do after this statement, we are trying to execute M1 dot calling. Okay, we are trying to execute what? M1 dot calling. M1 dot calling. Okay, but okay, what happens? M1 dot calling method is already available inside. Okay, but the control will check. The control will do so many things here. Okay, it will check if there any calling method inside the mobile class. Already there is a calling method inside the mobile class. Already there is a calling method inside the mobile class, and there is already another calling method inside the iPhone class. Let me do this. There is another calling method inside which class? iPhone class. Okay, one calling method is there in mobile class, as well as one calling method is that, one calling method is there in mobile class, and one calling method is there in iPhone class. The moment you give M1 dot calling, the question is which calling method needs to get executed? Which calling method? What happens? This calling method, okay, will be yes, my screen is visible. Sorry for the interruption. Are we good to proceed? Okay. See, I was telling you, okay, I am using M1 dot calling. M1 dot calling. Okay, this M1 is of what type? Mobile type. Okay, typecasting adaptation. This complete part is okay. This complete section is talking about what? Upcasting. Because we are using parent class reference to the child class object. Casting. Focus here. Casting. So what will happen? Okay, the moment you call calling method, okay, control will directly jump to the parent class object. Control will directly jump to the object of parent class type, right? And we will try to find if there is any calling method. Of course, in the parent class there is a calling method, but in the child class also there is a calling method. Okay, because of this upcasting, this child class method will override this parent class method. This child class method called this child class method, common method, or else I can say that specific method. This is going to, this logic will replace, this is going to replace this calling method. Okay, this iPhone calling method is going to replace the mobile calling method. Let me repeat, this iPhone calling method is going to replace the mobile calling method because of upcasting. The idea is, so here you have a calling method, right? Okay. And also you have calling, both the method names are same. This is an overriding concept. We will look at this overriding concept in the future topic, but for now both the methods are same. Okay, what I am doing it here specifically, I am calling a method by the name of calling, m1 dot calling method I am saying. So this m1 is of what type? Focus here. This m1 is of what type? Mobile type. Ideally the control has to go and find, ideally the control has to try to find for the calling method inside the mobile class, yes or no? Okay, it has to find the try to find the calling method in the mobile class. But what is happening here, because of this upcasting, because of the upcasting concept, if there is any calling method in the subclass, if there is any calling method in the subclass or the child class, okay, that is going to do what? It will replace this calling method. Are you getting this? So in order to understand this better, okay, now we are doing what? M1 dot calling. M1 is of what type? Mobile type. Control will go to the mobile and it will try to execute this calling method. At the time of executing, because of this upcasting, because of this upcasting concept, it will execute the calling method. But internally what will happen? This will replace this. Okay? It will be overridden. So subclass method, method of the with the same name will be overridden. Okay, the control will be executing this logic, subclass logic, because of upcasting, right? So, but when you add something like m1 dot camera, when you do this, what is happening? Okay, this camera method will be identified. Okay, it will try to check for the camera method in the m1 reference. M1 reference is of what type? Mobile type. Inside the mobile class, is there any camera method? There is no camera method inside the mobile class. Of course, this is not valid. This is not valid. But when you talk about m1 dot calling, this becomes valid because calling method is available inside the mobile class. But because of this upcasting, this void, the subclass calling method, why it is going to replace? Because both are the same name is same, logic is different internally, method return type is same, both are void and both are of calling, both names are what? Calling, right? This is going to replace this. Ideally the execution will be what? Calling from my phone. Okay, the output is going to be what? Calling from my phone. That's why we got the output like calling from my phone. Last one, right? So this is one of the advantages. If you want to restrict, okay, we want to restrict the child class specific method, we want to restrict this child class specific method. If I want to execute only the overriding methods of the parent class, you can use this upcasting. You can understand this better in the polymorphism topic, right? What is the advantages of upcasting? Okay, now you see, you focus here. iPhone of obj equal to new iPhone, no issues. Calls are direct. Obj dot calling, obj dot camera. Obj is of what type? iPhone type. Inside the iPhone class, we have calling method, we have camera method. Both methods will be, the logic inside this method will be executed. No issues with this. No issues with this also. Mobile obj1 equal to mobile. obj1 is of mobile type. The calling method inside the mobile class will get executed. No issues. But here there is not an issue. There is a little confusion. Why is there is a confusion? Because of upcasting. What are the advantages that we have with this upcasting? The reference type is parent type, but the object is of child type. Okay, when you use this reference variable to call a particular method, this method will be looked. I mean, the method is going to check for this method in the mobile class. Of course, there is a calling method, it's a mobile class, but because of this typecasting concept, this child class will sit here. Will is going to replace this. Child class method will be executed because of the same name. Okay, if the names are different, no issues. This method will be executed. If the names are same, child class method will be executed. Okay, let us run this. Same example. Okay, let me remove all this. Okay, let me keep only one line. Okay, m1 dot calling I am saying m1 is a mobile type, but typecasting has happened. Parent and child. Okay, so there is a calling method inside m1. We think this is going to get executed, but because of upcasting, this method is going to replace this. This logic will be executed because of upcasting concept. See, calling from iPhone. Which one is calling from iPhone? What we are expecting to get executed? Calling from mobile. But what is getting executed? Calling from iPhone. Right? Let us change this method. Let us change this method as calling one. Both are different now. Okay, if I run this now, this method will get executed. Calling from mobile because they are very specific. Now it is very specific. Calling from mobile. The moment it finds the same method names in parent class as well as the child class, the child class method will override the parent class method. So this will be displayed in the console. If it is not same, this will get executed. If it is same, this method will get executed. Not same, parent class. Preference will be for parent class. If the parent class is finding the same method name in the child class, this will replace this. This will, directly replace this. Making sense? Upcasting. This will make more sense when we start discussing about the polymorphism concept. Only one difference is there. Just try to understand one difference. Let me repeat the difference. You have three options now. Till now we got three options. Okay. Object can be created for child equal to child. Child, new child. Yes or no? Or parent, new parent. Or parent equal to child. Okay, this is ordinary, this is also ordinary, this is upcasting. This topic is what? Upcasting. What are the advantages? You can block the non-specific methods. You can call the specific method from the parent class. You cannot call any method from the child class. But if both the methods are having the same names, child class method will replace the parent class method. Can I call camera method? I cannot call camera method. So I cannot call camera method here because camera method is not inside the mobile class. Then what method I can call? I can call calling method because calling method is part of mobile class. But there is the same type of method in the subclass. If it is same, this will replace this. If it is not same, this will get executed. So if it is different, okay, I am doing it calling one. Okay, this will get executed because this is calling one. If both are same, subclass method will get executed. Lot of confusion is there. I understand that. Okay, try to repeat this video. Tomorrow downcasting topic is there. Okay, that part will make more sense. Okay, and trust me, the moment I introduce polymorphism concept, these things will go just like that. You can blow with the flow. Just try to remember this theory part. Okay, this theory part, so that you can convert this theory part into the diagrammatical representation for the better understanding. Revise this topic. This is always a topic of confusion. Okay, anyone who is listening to this for the first time will get confused. But what are the things that we have got so far? What are the advantages that we have with the upcasting? This is the advantage. What is it? By using this, you can replace the child class method can replace. Right? So now it will not make any sense. When I introduce collections topic, okay, this will make more sense. This concept is called as runtime polymorphism. right? Polymorphism topic. Over there, it will make more sense. Tomorrow we'll discuss downcasting. Any questions for me? Of course, you might be having bundles of questions.